Okay. Good morning, ladies and gentlemen. First, welcome to join this 5G workshop. And this is Pan, come from a wireless department. And today we have 1 hour, and we can talk about something about 5G because time is limited. So for this workshop, we focus on the 5G motivation and industry progress. And in this course, or in this workshop, we want to introduce 3 questions, or we talk about 3 questions. So what is 5G? Why we need 5G? And what can 5G do? So now we know 5G topic is very hot. Many public operators and even private companies, they deploy the 5G network, or they plan to deploy 5G network for public service or for private service. So in this workshop today, now we introduce this 5G and these 3 questions. Answer these 3 questions. For this workshop, for today's workshop, we focus on the 3 questions, and here this is our training contents or workshop contents. First one is our 5G evolution. In this part, in this topic, we will introduce what is a 5G, why we need a 5G. And in the part 2, 5G protocol standardization, we will introduce a 5G standard because we know 5G, actually this is a CT technology, communication technology. But now we talk about much more about ICT. But if we focus on the 5G connection function, 5G is a communication technology. So we know for the CT, for the communication technology, standard is very important. So in the part 2, we will talk about 5G protocol standardization. I think many guys, you already know 5G starts from 3GPP release, start from 3GPP release 15, and now release 16 will be frozen maybe in 2 months, in the following 2 months, maybe in June. So in part 2, we will talk about something about 5G protocol standardization. The last part is 5G industry chain, because if we wanted to push 5G, if we wanted to deploy 5G network as soon as possible, the industry chain is very important, from chipset, terminals, network equipments, and applications, services. So in the last part, we introduced 5G industry chain. So now actually, for the 5G, from the chipset, terminals, network equipments, and some application services already. So now it's time to deploy 5G. First, we introduce 5G evolution. If now we talk about 5G, so we know we have first generation, second generation, third generation, fourth generation. So now we know, I think all the guys, we are familiar with 4G. So now many users, we already use MBB service. We have many mobile terminals, like cell phone, like a pad, like a data card, or dongle. So now 4G is already very popular. But from this slide, we can get some useful information. So from first generation, 40 years ago almost, 1980s, first generation, this is the first generation. And in the first generation, mainly it provides voice service. And 10 years later, we have the second generation, for example, GSM. And for the second generation, mainly we can provide voice service and short message service. We know 20 years ago, maybe 20 years ago, short message service is very popular. But now I think short message service not very popular, maybe limited used. Most users, most subscribers, we want to use iMessage, right? Instant message, like WhatsApp, like WeChat. And 10 years later, in 2000, we have 3G. Now, maybe in some countries, we still use 3G. Now no 4G, only 3G. For 3G, internet service introduced. In first generation, second generation, we cannot use terminal to serve internet. But from 3G, we can use our terminal, we can use our cell phone to serve internet. And we can read news, and we can read some, for example, support news or other interested news. So this is a 3G. And now in 2010, we know 4G. For the 4G, the most important service is a video service. Why? Because in 4G, we already can provide broadband service. In 4G, we call this service as MBB, mobile broadband, because we know in 4G it can support 100 megabps, even high speed, like 300 megabps, 600 megabps, even 1 gigabps. So 4G, it can support high throughput, high data rate. So we can support video service. So now, 5G. So what will 5G can support? What kind of service does 5G can support? Now I think you already get much more news, maybe from internet. We know, or maybe in the future 5G can support virtual reality, VR service, and maybe support V2X, vehicle to everything, connected car service, even the driverless car service. So also support Internet of Things service, like smart city, smart home. So in the future, 5G will support many new services. But yes or no, maybe we still need to check. But maybe this service will be very important or will be very popular in 5G. So now we talk about too much about 5G, but actually 5G, this is a nickname of the fifth generation communication system. For the 5G, the official name is RMT 2020, International Mobile Telecommunication 2020. This is a 5G official name, but actually we call 5G. It's okay, no problem. I think all the guys will know what this. But actually, the ITU defined the 5G official name IMT 2020. So this is a mobile network evolution from first generation to fifth generation. Now we are here. So for the mobile network evolution, and we find from first generation to fifth generation, more and more services can be supported. So new service, it means new network requirement. Also for the 4G network, for the 5G network, they should support many different services. And we know maybe different service, different QoS requirement. Some service, they need a high speed, for example, video service or like a VR service. And some other service, they need massive connections, like IoT, Internet of Things. And or some other service like V2X, connected car service. For this service, we need low latency. So we find, especially in 5G, it will support many different services. And we also find different service, different QoS requirement. For this part, a little different with 4G. For 4G, mainly focus on the mobile broadband service, high throughput service. But for 5G, many different services, and different service, different QoS requirement. So in 5G, a little special. So here, this is the challenges in 5G. Now we already introduced, in the future, 5G will support IoT service, will support VR, even AR, MR service. And we know for this service, we need high speed, high throughput. And then the connected car service, V2X. So for this service, we need a low latency. So all of these challenges in 5G. So in 5G, the challenge is high throughput, large connection, and low latency. So if 5G want to support many different services, 5G should handle these challenges. 5G should support ultra high throughput, ultra large connections, and ultra low latency. So this is 5G's challenge, and 5G should handle this. So based on these three challenges, and we know, and based on the new services like IoT, VR, or V2X, ITU defined 5G vision, or RMT 2020 vision. So in 5G, what does a 5G will be like? What does a 5G can support? So ITU, we know the ITU, International Telecommunication Union. So ITU defined the 5G vision, defined IMT 2020 vision. So I think this picture, many guys, you are very familiar. And this picture comes from ITU report, from ITU 5G report. And ITU defined three application scenarios in 5G. EMBB. For EMBB, enhanced mobile broadband. Why we call it the EMBB? Because in 4G, we call it as MBB, mobile broadband. So in 5G, we call it as EMBB, enhanced mobile broadband. Because in 5G, we can support we can support a high throughput. So we call it the EMBB. So for this service, we can support high throughput, 10 gigabps, even 20 gigabps in special scenario. So high throughput. But this throughput, we know this is peak rate. And this is not user experience. This is not user experience rate. Maybe later we have a question. So we know in 5G we define high throughput, high peak rate, 10 gigabps, even 20 gigabps. But this is peak rate. So how about user experience rate? So I think for most subscribers, we focus on the user experience data rate. So how about my cell phone? How about my terminal can support data rate or throughput? So my cell phone supported 10 giga, support 20 gigabps, or maybe only support 1 giga or 100 megabps. So user experience also very important for our common subscribers. So this is the first application scenario, EMBB, enhanced mobile broadband. Second application scenario is MMTC, massive machine type communication. So based on the name, we will know this MMTC will support IoT service, but we call it as massive because in MMTC application scenario, 1 square kilometer, we can support more than 1 million connections. So we call it as massive. I think some guys, maybe you know, in 4G, 1 cell, we can support almost 1,000 connections. But in 5G, higher requirement, 1 square kilometers, more than 1 million connections. So that's why we call it as massive MTC, massive machine type communication. Because in the future, more and more items, more and more things they will access into the network. Even, for example, even my glass and my shoes and our air condition, our fridge. So more and more things will access into the network. So we need large connections. The last application scenario, URLLC, ultra reliable, low latency communication. For this application scenario, we need low latency, 1 millisecond. So for this 1 millisecond, maybe we will compare. We can compare with 4G. 4G, the typical latency, typical time delay, 30 milliseconds or 50 milliseconds. So this is a 3 application scenario. So ITU defined 5G region, and in the future 5G will support this capability, and 5G can support different application scenarios. So for different application scenarios, now we already have some typical services. For example, EMBB application scenario, VR service, or AR or MR. So for the virtual reality, this service, we need a high throughput, we need a high data rate. So this service is suitable for EMBB. And for the URLLC, for example, connected vehicle, V2X, and in the future, driverless car. So for this service, we need a ultra reliable and low latency. And also for the intelligent manufacturing, so we also need a low latency for industry control. So this is the URLLC services. The last one, MMTC, we already introduced. In the future, more and more things, more and more items, they will access into the network. So connection is very important. And based on the MMTC, we can support large connections. So here we have a data. This data comes from Huawei. 5 years later, in 2025, all over the world, maybe 100 billion connections. But in this 100 billion connections, for population, for people, only 10 billion. Others, 90 billion for things. So in the future, we need, in the 5G, we need large connections. And also maybe in the future, in the 6th generation, in the 6G, we still need large connections. So this is a 5G vision defined by ITU. We have these 3 application scenarios. So for the EMBB, URLLC, and MMTC, we already know we have some typical services. For example, EMBB, we have VR service. I think now for the VR service, it's very common now, because in the shopping mall, in the CBD areas, you will find there are some shops, they can provide a VR service, and we can try. So for the VR service, virtual reality service, we have now we have 2 different VR types. The first one is mobile VR, another one is PC VR. For the mobile VR, we only need to buy a VR glass, and then we can use our cell phone, and we can download a VR video, and then we can use mobile VR. But we know for the mobile VR, the experience is not very good, and sometimes maybe headache, because maybe the video is not very clear. But for the mobile VR, we know the VR glass is cheap, so this is benefit. But actually the experience not very good. Another one is the PC VR. For the PC VR is popular, but mainly used in game. For the PC VR, we know here we have a VR glass, and this VR glass connect with a PC laptop. And for this PC, we need a high performance GPU. So for the PC VR, the performance is not bad, but a little expensive, because this high performance PC, For the PC VR, because of the laptop, because of the PC, because of the VR glass, a little expensive. So not now. It's popular, but not widely used. In the future, we want to decrease VR terminals price, and we also want to improve experience. So cloud VR. For the cloud VR, we only need a simple VR glass. But in this VR glass, we can integrate 5G chipset, or maybe other communication solutions. For example, maybe Wi-Fi 6 chipset. And this VR glass connect with a data center, connect with the cloud. If we use the 5G, so this is through the 5G, the VR cloud VR glass connect with the data center, connect with the cloud through the 5G network. So based on the cloud VR, we can process the video, we can process the online game in the data center, in the cloud, and then we can transport the data to the cloud VR glass. The cloud VR glass receive the data and display the video. That's okay, that's enough. So for this VR glass, we do not need high performance. We do not need high performance GPU. So for this VR glass, the price not very high. And another benefit, now for the for the VR service, the content is very important. The video, the game, very important. We should control the video. We should control the game. If all the guys they copy paste, so this is not good for the VR industry. So based on the cloud VR, all the contents, no matter this is a video or a game, we can deploy, we can storage the game video in the cloud, so we can control the content, we can control the video, control the game easily. So this is a benefit of cloud VR. But for this cloud VR, if we wanted to enable this cloud VR, the cloud data center should transport data to the VR glass. So we need a high speed. We need high speed. So 5G is okay. 5G can support high speed, even 10 Gbps. But for the VR, we have a different level. We have an entry level. We have a ultimate experience level. So different VR experience, we need a different throughput. We need a different data rate. So in the future, maybe we need the best VR experience. So the connection, we should support 9.4 Gbps. And another one, time delay. We need low latency, because from the cloud data center, transport the video, transport the game, processed video to the VR glass. If the latency is too long, if the time delay is too high, experience not good, maybe headache. So if we wanted to enable deploy cloud VR for the network, for this network, it should support high speed and low time delay or low latency. So 5G is suitable. But actually, 5G, this is not the single choice. Wi-Fi 6, this is another choice. So this is a cloud VR. So in VR service, especially cloud VR, we need a 5G, because 5G can support high speed, high throughput, can support low latency. Another application scenario, MMTC, massive machine type communication. For the MMTC, we need large connections because we know now, like shared bicycle, the shared bicycle in China is very popular, and smart city, and we have many things. These sensors or these bicycles, they should connect into the network. So we need a mobile network. So IoT builds a better connected society. Now we know, based on the 4G, the NB-IoT, eMTC technologies are very popular. So in the 5G, we still need a machine type communication technology. So this is a IoT application, MMTC scenario. The last one we know is URLLC application scenario. For the URLLC application scenario, we need a ultra reliable and low latency. So for this application scenario, we find connected car. For this service, we need ultra reliable and low latency. So here, there's an example. Now, for the driverless car service, now there's our car, and here maybe there's a passenger cross the road. So for this driverless car service, this car should stop right now. But for the V2X service, vehicle to everything, right? The car should connect with the network side, because for the V2X we have a vehicle to vehicle, vehicle to pedestrian, vehicle to infrastructure like traffic lights, or vehicle to network. For the V2X service, we deploy the V2X server in the cloud. So the driverless car, in this driverless car, we have many sensors, we have many cameras, we have many radar, and these sensors detect the nearby information and transport the information to the V2X server, to the cloud, and then the cloud can make decision. The car should shut down right now. So we can find in the driverless car application scenario, the car detect the emergency issue and transport this information to the cloud, to the V2X server. And then the V2X server process this information and give feedback to the car. And then the car should take action. Stop right now. So for this transport, for this transmission, we should use mobile network. So we have several choices, 3G or 4G or 5G. 3G, the typical system delay, 100 milliseconds. 4G, 50 milliseconds. And 5G, 1 millisecond. So we can check. Because of this time delay, if the time delay is 100 milliseconds, before the control information, before the car received the control information, the car already moved forward 3.3 meters, maybe accident. But if we use a 5G, the car only move a little. But now for the 5G network, we still cannot support 1 millisecond for end-to-end. The car transmits the message to the 5G base station. The 5G base station transports the message to the transport network, and then through the transport network, the message, the control information, the information data transported to the core network to the cloud data center, and then return back. So based on the current 5G network, we cannot support 1 millisecond for end-to-end scenario, but almost now we can support 5 millisecond, and sometimes maybe 4 millisecond. So this latency, this time delay, actually is enough for driverless car application scenario. But we know in the future, maybe low latency, maybe the end-to-end we can support 1 millisecond. So we can find low latency is very important for connected car service, especially the driverless car service. This is 3 application scenarios in 5G, and for every application scenario, we have some typical services, typical application. So here a summary. Now we introduce 5G. What is 5G, and what does 5G can support, can do? So for 5G, it can support low latency. It can support high throughput. It can support large connection. Compared with the 4G, we increase network capability a lot. So now we get one conclusion. 5G can support many different services, or we have 3 application scenarios. But we only have one 5G network. For example, in one city, we have one company or one operator. We only have one 5G network. But this 5G network should support low latency service, like driverless car. This 5G network should support high throughput, also should support large connections. But we know different service, they have different service requirement, different network requirement. But we only have one 5G network. So this 5G network should support all the services. How to do? In 5G, 5G will support network slicing. We can separate one physical 5G network into several logical networks. One logical network, one network slice. Different network slice, they are independent. And different network slice, different QoS, different service requirement. So based on the network slicing, 5G network, one 5G network can support different services, can support different application scenarios. So for the network slicing, how to enable network slicing, or how to realize network slicing. Core network, we can use NFV, network function virtualization. Transport network, we can use SDN, software defined radio. Wireless network, we can use DSS, dynamic spectrum sharing. But in Huawei, we have another name. We call it as Cloud Air. This is a key KPI of a 5G network. So 5G will support many different applications, many different services, and we can support low latency, 1 millisecond, high throughput, 10 gigabps, even 20 gigabps in special scenario, and large connection, 1 square kilometers, 1 million connections. And 5G should one 5G network will support many different services. How? Network slicing. So this is a key KPI of 5G. So now we introduce what is a 5G, the 5th generation of a mobile communication system, and the official name is IMT 2020, right? We can go back. The first question, what is a 5G? So the 5th generation, right? The official name, RMT 2020. And then why we need 5G? Because we wanted to support new services like IoT, like VR, virtual reality, VR, AR, even MR, and then connected car service. We can use V2X, vehicle to everything. And actually, maybe we also have some other new services. So this is why. And the last question, what does 5G can do, right? What does 5G can support? Now 5G can support EMBB, application scenario, URLC, application scenario, and MMTC. Now we already answered the 3 questions. So what is 5G? Why we need 5G? What does 5G can do? So this is a 5G evolution. Now the second topic is 5G protocol standardization. Now we know in our RCT domain, we have IT, we have CT, we have information technology, we have communication technology. We know IT is more open. We have in IT domain, we have a product first, and then we have a standard. But in CT, not very open. For the CT, for the communication technology, we have a standard first. We define standard first, and then we have equipment, and then we have network, we have service. So for CT, standard is very important. So in the second part, we introduce the 5G protocol standard. Now, if we talk about the 5G standard, we have 2 important international organizations. First one, ITU, we already introduced, International Telecommunication Union. ITU define 5G, define 5G vision. What does the 5G like? The key technologies, or the key parameters. What's the high speed? What's the low latency? What's the massive connect? What's the large connection? ITU define the vision of the 5G will be like this. And then another international organization, 3GPP. 3GPP will provide technical standard, something details about about technologies. So this is the ITU and 3GPP. ITU define the target, and then 3GPP realize this target. So now in our mobile network, 3GPP, a 3rd generation partnership project, it's very important. This is a very important international organization, and 3GPP define 3G, define 3G standard, define 4G standard, now also define 5G standard. For 3G standard, WCDMA are very popular, and 4G standard LTE, and LTE Advanced Pro. And now 3GPP also define 5G standard. So for the 3GPP, the first release is the release 99. This release is related to 3G. And in release 8, first release is the release 99. This is WCDMA. And then in release 8, we have LTE. And in release 12, we have LTE Advanced. And then we have LTE Advanced Pro in release 13. Now in release 15, we have 5G. But for the 5G, 5G starts from 3GPP release, and then start from release 15, and then release 16. But we have one problem because for public operators, they still have 3G, they still have 4G. So in new 5G standard, we also should think about 3G network. We also should think about 4G network. So for the 5G standard, actually we have two parts. First one is 5G new radio or new technologies, new network architecture. Second one, second part, we can call it as ELT, LTE evolution. So for the public operators, for their 4G network, the 4G network can evolve to ELT. And the ELT network also can access into the 5G, also can provide some limited 5G service. So in 5G, we have two parts. One is a new radio, one is a ELT. So this is a little special because we should think about original 4G network. So we have two parts. But actually, we focus on the new radio because this is a new part, new technology, new network architecture. So for the 5G standard, we separate 5G standard into two parts. One is release 15, one is release 16. Because in 5G, we wanted to support eMBB, URLLC, and MMTC services. But we have a lot of work to do. So we cannot, in one release, we cannot finish all the tasks. So we design two release. First release 15, mainly focus on eMBB application scenario, mainly focus on the eMBB technology. Release 16, mainly focus on URLLC. At the beginning, in release 16, we also wanted to define MMTC, but because of NB-IoT network and eMTC network, because we know NB-IoT network, narrowband Internet of Things, and eMTC network, these two standards also defined by 3GPP. So we wanted to reuse NB-IoT and eMTC. So for the MMTC standard, we postpone, we delay MMTC standard. So actually this standard in release, we will define MMTC in release 17. So this is a 5G protocol standard. For the 5G, especially the 5G standard, so we know we have two different release 15 and release 16. Release 15, mainly we focus on eMBB, and we also did some URLLC task, but mainly we focus on the eMBB, and we also define some technologies related to URLLC. But for the release 15, because of other standards competition, the 3GPP speed up protocol standardization. So we separate release 15 into two parts. One is a non-standalone, one is a standalone. So we can finish NSA non-standalone standard a little earlier. actually because of the competition. And then we have standalone, and then we have let drop. But this part something details, and I think some guys know this one. We call it as phase 1.1, and this is phase 1.2. Let drop we call it phase 1.3, and in release 16 we call it as phase 2. So this is a 5G release 15 and standard, and release 16 standard. Non-standalone, it means 4G and 5G, they should work together. 4G network control the signaling, process signaling. 5G network only provide user plan, data connection. Standalone, 5G network can work independent. Let drop is a special networking, but now maybe we do not need it. So this is release 15 and release 16. So in release 16, we wanted to finish all the application scenarios, but actually MMTC a little special. Now in release 15, in release 16, we do, because of NB-IoT and eMTC, we do not define MMTC technical standard. MMTC will be delayed to release 17, maybe even later. So in different release 15, release 16, we define many new technologies. In release 15, now we know release 15 standard. Almost 2 years ago, release 15 standard already frozen, and many companies, many telecommunication vendors, they can provide 5G network equipments based on release 15, and now release 16. For release 16 standard, 3GPP based on the original plan, 3GPP will finish release 16 standard in 2020 March, but because of the virus issue, now maybe 3GPP will froze release 16 in 2020, in June 2020. So in release 15, release 16, we define different technologies. Release 15, this is a basic version. So we define a new waveform, new numerology, and coding modulation. But for this part, something details about the technology. If you are interested, you can attend Huawei HCIA 5G certification. So this is a release 15 technologies, and in release 16, now maybe 2 months later, release 16 protocol standard will be frozen. In release 16, we have some new technologies. We have new multiple access technology, and we also will define device-to-device NRV2X and industry IoT or unlicensed frequency band to support vertical industry application. So for the technical part, if you are interested, you can attend Huawei HCRA 5G certification. Here, I list several key technologies in 5G new radio, in 5G NR. First one is wideband. For the 5G, it can support high throughput, high peak rate. Why? Because wideband. You know, for the communication technology, we have a Shannon formula. If we wanted to support a high throughput, we can, for the capacity, channel capacity equals to band width we know this Shannon formula. Capacity equals to this formula. This is the band width. So if we wanted to increase capacity, throughput, so we can increase band width. So in 5G, we can support a high throughput, 10 Gbps, 20 Gbps. Why? One reason, wide band. In 4G, mainly the band width is 20 MHz, and in 5G, 100 MHz, even 400 MHz. So that's why we can support a high capacity, high throughput. Another one is high order modulation. In 4G, mainly we support 64 QAM modulation. Now in 5G, we can support 256 QAM modulation, and maybe in the future we can support 1024 QAM modulation. So high order modulation, we can also support high speed, high throughput. And another one is massive MIMO. We know MIMO, multiple input, multiple output. Now here, we call it as a massive MIMO. So we can support, for example, 64 antenna for TX, 64 antenna for IX. So we can use space resource. So we can support high throughput. So we should modify this Shannon formula. We can update this Shannon formula like this. Capacity equals to mean TX number or IX number. So why we can increase throughput, increase capacity, we can also increase antenna numbers. In 4G, 2D2R, 44R, 8D8R, but now in 5G, 64 TX, 64 RX. So for the antenna, we have the 64 antennas for transmit, 64 antennas for receive. So we can use spatial, we can use space capacity. So we can also increase network capacity. We can also increase throughput. And then we also have other new technologies like FOFDM. Based on the FOMDM, we update the filter, the bandpass filter, and we can decrease guard band, and we can improve spatial efficiency. And another one is coding, channel coding. I think for the channel coding, there are many news from internet, like Polo coding and LDPC coding. You know, Huawei push Polo coding, and Qualcomm push LDPC coding. But we know in release 3GPP release 15, the conclusion. Control channel, we use Polo coding. Traffic channel, we use LDPC coding. And we also have other technologies like numerology. Numerology can support flexible service. So 5G, one 5G network can support many different applications, many services, and different services, different network requirement, different QoS requirement. Based on the numerology, 5G can support many different services based on the same network. Last one is SUL. This feature is used to handle uplink coverage issue, because for the 5G we use a high frequency band for communication. So for the uplink signal is weak. So we, based on the SUL feature, we can handle the weak uplink coverage issue. This feature is also pushed by Huawei. Now in 5G, we have many new technologies. Based on these new technologies, we increase throughput, we decrease latency, we increase connections. So in the future, 5G network will connect much more people and also connect many things. So in 5G, mobile internet and mobile IoT work together. Also for the technology part, if you are interested in the technology part, you can join Huawei HCIA or in the future HCIP, HCIE 5G certification. You can get much more. So this is a 5G protocol standardization. The last part is industry chain for the mobile network. If we wanted to deploy the new mobile network, industry chain is very important. Now, 5G network, 5G large-scale communication environment is ready, because if we wanted to construct a mobile communication network, we need a chipset, we need a terminal, maybe UE, maybe CPE, and we also need a wireless network like a base station. We also need a transport network. We can also call it a bearer network, and we also need a core network. Now, everything, all the equipments are ready, and here we also have a data time required to reach 500 million subscribers globally. In 3G, we spend 10 years and we get 500 million subscribers. In 4G, we use 5 years, but 5G, 3 years, even maybe 2 years. So now, 5G, the 5G network development is quickly, and more users they want to use 5G service, and from the industry chain we can find from chipset, terminals, base station, transport network, core network, everything is ready. So for the industry chain, maybe we should pay much more attention to the modem chipset. We know now for our terminals, no matter this is 4G terminal or 5G terminal, if the cell phone wants to connect with the network, we need a modem. And now, Qualcomm, Intel, Samsung, MTK, and Huawei, Thales, these companies, they can provide a 5G modem chipset. For Qualcomm, start from X50 and now X55. This X55, I think this Qualcomm chipset is widely used in many 5G cell phones. It can support non-standalone networking and standalone networking. Now we know just in this recent 3 months, Qualcomm published X60, but maybe for the X60, several months later, the cell phone companies will provide a 5G cell phone based on the X60. And Intel already gave up. This is Intel's 5G modem chipset, but Intel already gave up. Samsung also can provide a 5G modem chipset, but Samsung's 5G modem chipset only used by Samsung's terminal, used by Samsung's terminal. MTK also can provide a 5G chipset, modem chipset. Also, many companies, many cell phone companies, they will integrate MTK 5G modem chipset. And then Huawei provide a 5G modem chipset 2 years ago. The first one is first chipset is 5G01, and now the commercial chipset is Balong 5000, and this chipset can support multi-mode. One chipset supports 2G, 3G, 4G, 5G, and this chipset supports NSA networking, also support SA standalone networking, and this chipset now widely used in Huawei cell phones and Huawei Honor cell phones. So this is a 5G modem chipset. Now, in this year, maybe in September, Huawei will provide new SoC. In this new SoC, system on chip, maybe it will integrate new 5G modem. So this is our 5G modem chipset, and now we know this is Huawei 5G modem chipset, Balong 5000, and this 5G chipset supports multi-mode 2G, 3G, 4G, 5G, and also support high speed. We can check this is downlink, uplink speed, and also support SUL. So we call it as uplink, downlink, decoupling, and also support non-standalone networking and standalone networking. And this chipset also can support V2X, vehicle to everything. So another one is terminals. Now many companies already provide 5G terminals. For example, Huawei can provide 5G terminals like Huawei 5G CPE Pro, Huawei Mate X, Huawei Mate 30, and so many cell phone companies already provide 5G cell phone. Now all over the world, for the 5G terminals, for the 5G cell phones, maybe more than 60. So this is the 5G terminals. Now many 5G terminals. The last one is network equipment. So the chipset, 5G chipset is ready. Modem chipset is ready. Terminal ready, no matter CPE or cell phone. And then network equipment. From this is Huawei network equipment. From base station, this is the antenna. Base station and transport equipment, core network equipment. All the network equipments are ready, and we can support many different deployment scenarios. We can support macro site. We can also support indoor coverage solution. The small site, we call it as a small cell solution. This is Huawei left side solution. And we can also support natural coverage and heavy traffic hot support area solutions. So now, for the network equipment, everything is ready. And actually now we already have several 5G networks in America, in South Korea, in Japan, in China, in Europe, in Middle East. Now many 5G commercial networks. Okay, this is 5G motivation and industry progress. In this course, we talk about 5G 3 application scenarios, eMBB, UIRC, and MMTC, and we also introduce 5G protocol standardization. The last one, we introduced some basic information about 5G terminals and networks. Okay, thank you.